if you had an Algebra 2 course, you've seen some of these things before, so hopefully this is not all brand new to most of you. But properties of the complex number system. The complex number system contains all real numbers. So real numbers are in the complex number system. The complex number system contains a number I such that I squared equals -1. That's its formal definition of what I is. So it's basically a number that we're defining to be so that if we square it, we end up with a negative value, -1. Addition, subtraction, multiplication, and division of complex numbers obey the same rules of arithmetic that hold in real number system, with one exception. The exponent law holds for integer exponents, but not necessarily for fractional ones. And that's kind of not stated very clearly, because how we perform the addition, subtraction, multiplication, and division of complex numbers in some ways mirrors some of what we do with real numbers, and in other ways they don't. There are some really key differences. Every complex number can be written in standard form, a plus bi, where a and b are real numbers, and that's the important part of that. One of the things that they don't make mention here, but it becomes an important part of this, is that the complex numbers in all these operations are closed systems, which means if I add, subtract, multiply, or divide two complex numbers, or I raise a complex number to a power, or do many other different operations with it, I end up with yet another complex number, which means I should be able to get a number that's written in a plus bi format. So when we come up with an answer in complex numbers, it needs to be in that final a plus bi format. If I don't have it in that format, I need to work out the problem a little bit longer, a little bit more, until I'm able to do so and put it into that format. So kind of going into what's going on here. So if I squared equals -1, it means that I itself is the square root of -1. Something else we're not used to being able to do, square rooting a negative number. But in the complex number system, in the imaginary number I, that's what they call it, the imaginary number, it's perfectly allowable. So when I look at values of these things, of course, I to the first is just I. When I square I, as we talked about before, it's -1. That's how we came up with it. I cubed is I squared times I, just using basic exponent properties. And I squared is -1 by substitution, so -1 times I would be -I. I to the fourth is like taking I squared and squaring it, which is like taking -1 and squaring it, and I would get equal to 1. And if I did very similar things for I to the fifth, I to the sixth, and I to the seventh, you would notice that we repeat the same pattern. I mean, we ended at 1, went to I, -1, I to the eighth would be 1 again. So we keep repeating the same pattern in both directions, because I to the 0, much like any other number raised to the 0 power, is still 1. But we can kind of figure that out, because what usually follows 1 in this pattern of numbers here, when I take powers of I, well, what follows 1 is I. So when I look at I, so what would precede that? Well, 1. What would precede 1? Well, -I. And if you work out -I, or I to the -1 power, you would find out that you would have -I as well. We don't get so much into the negative exponents, and the I to -1 being -I is something that you would have to understand a little bit more about dividing complex numbers, which we're going to talk about in a few slides from now. But this pattern does exist in both directions. So that when I look at this, I mean, each power of I is going to end up being one of 4 things: either 1, I, -1, or -I. That's it. That's all raising I to a power is going to do. It's going to make it fluctuate between 4 possible values.